So this morning we heard from academia, we heard from the government, so now it's industry's turn to tell us basically how they're exploring quantum applications today, right now, right? So it's not just the theoretical anymore, it's not just the if or when or anything like that, but the people here, some of them had actually very, very mature quantum initiatives and quantum projects that they're working on right now. So we're gonna hear it from them. And to help us do that, we have a great moderator. His name is Sean Maguire. He's a partner at Google Ventures. He did his PhD under John Preskill, and he's been tracking the quantum computing field very, very closely, and he's already made several investments in the quantum computing field. So with that, I'd like to have Sean come up and kick us off.
Hey, everyone. Thanks so much for being here. Thanks to the QC Ware folks for having us. Great event, 2 years in a row. Punching above your weight for where the field's at. So we've got a great group of panelists. First one is Paul Burchard, who's head of research and R&D and also a managing director at Goldman Sachs. And we've also got Thierry, who is head of Airbus's Blue Sky efforts. And Oliver Wick, who goes by Ollie, who's the manager of the Open Innovation and Technology Scouting efforts, including quantum computing at BMW. And I'm actually really sorry. I skipped Michael Hayduk, who is the chief of Computing and Communications Division at AFRL. And last but not least, we have Jose de Ponte, who's an EVP Beyond Core, which is the new digital business unit at BBVA Compass. All right, everyone, thank you for being here. I'm going to try to get to the bottom of how all your procurement processes work and open things up for the audience. But first, just some very quick backgrounds around how your divisions are structured and kind of a little bit more around how you think about quantum computing in your companies. So we'll start with you, Paul. We'll just go down.
So yeah, at Goldman, we just last year started a new research and development engineering group that works all across the firm. We take on longer-term projects than the business normally would, but we work closely with actual operating businesses on each project to make sure that there is consistent incremental delivery and finally looking at the longer-term end products. So.
Yeah, for us at Airbus, I think our link to quantum computing goes back to already a couple of years ago. We were early investors in QC Ware. That for us was sort of a first gate, a first window into the topic. We've really tried to understand the technology better. We have had a few projects already in this space. My organization, Blue Sky, sort of serves as the interface, the entry port into the rest of Airbus. And we really try and facilitate a close proximity between our own internal knowledge in aerospace and the external ecosystem on quantum computing.
Yes, okay, and my name is Olli from BMW, from W Research. And I'm from background not a physicist, I'm an electrotechnical engineer, and I'm responsible for all buzzword technologies. That means in former times that was augmented reality for some years ago, that was blockchain, and now quantum computing. And my task is to analyze the actual maturity of quantum computing, to know the providers, to build up a network, also to other cross-industries such as Airbus, and then to prove all the technologies in order to what is the chance for BMW, what is the risk for BMW, and after them I will build up this organization and then will I fade out and hopping to the next technology.
So at Air Force Research Lab, we heard a little bit about our program from General Cooley just in the last talk. In my division that I run, the Computing and Communications Division, lies the Quantum Computing Group. And an important point there is that we're not interested in developing hardware for quantum computing, but we're looking at how we can use it. So in terms of the software algorithm development, that squarely fits in our areas of interest. We've been steadily growing our investment the past few years. We started out very small in terms of people working the area and as well as partnerships. And as you heard from General Cooley, we're very interested in partnering with a lot of industry that's out there, as well as small businesses in terms of looking at applications and what we can do both now and in the longer term for quantum computing.
I work for NDB, which is the research and disruption arm of BBVA, which is a large international bank headquartered in Spain. A lot of what we do in our group is explore emerging technology and things that are going to hit financial services in 3 to 5 years from now. We borrow a few pages from the DARPA book, so we try to start not with the tech, but with the problem, and that's how we got into quantum, trying to solve something else, trying to solve, in essence, fraud in digital payments, which in the end is a large optimization problem with many, many features, and that was suited for this tech. But still very early days for us in quantum.
Perfect. So I'm going to start this next question with Paul, because this is something we've been talking about for years now, but we'll open it up to everyone after. As Preskill coined with this NISC word, near-term quantum computers are going to be noisy, error-prone. How are you guys thinking about designing algorithms for kind of real-world noisy machines rather than 10 years from now idealized, machines?
Yeah, so I mean, I think I was here at last year's Q2B conference and heard John's keynote then talking about NISC, and that left a pretty big impression on me. And I think we've really thought about like what can we, in order to be able to do something in the near term or even the medium term, we have to think about real quantum computers and not ideal quantum computers. So there are all kinds of quantum algorithms that have been proven to be good performing on sort of some ideal system. But in the meantime, we have noisy qubits. We have a variety of different hardware approaches to quantum computing, each of which does certain things well and other things not as well. And we need to design algorithms that will do something useful on that kind of hardware. And so in particular, we've been looking at noise-robust algorithms. And so that's where my personal focus has been on like designing algorithms that do something, but take into account the noise on the quantum computer. And I would really encourage everybody out there who's thinking about algorithms to sort of redirect their efforts in the meantime to thinking about either noise robust or like how do we do something that adapts to the different characteristics of the different hardware, because that's what's going to be needed in order to make a real business impact in the near, like say, even medium term. Particularly because even in the long term, let's say we have 1 million physical qubits on a chip. If we have to error correct by gathering 10,000 of those qubits into one logical qubit, that's a very small problem we're still going to have. So if we can make real use of those 1 million qubits, taking into account all the imperfections, then that would be a real breakthrough.
Yeah. Anyone else want to take this question?
Yeah, I think echo also Paul's sentiment about the fact that we need to try and work with the state of quantum computers as they are going to be in the near term and medium term. And that's not only looking at algorithms, I think algorithms is a big part of it, but also asking the questions, how might we pair that technology, which is still young, emerging, small potentially in size now, with some classical tools to develop some type of hybrid in between the two, leverage where possible the benefits of quantum computing, but at the same time also benefit from some of the classical systems that we have. So looking at that interface closely is also, I think, part of it.
Yeah.
Okay, some words from BMW. What I have learned during the proof of concept phase, together with QC Ware, BMW's actual challenge is to identify the right use cases and combine that with the bunch of algorithms. That means I see not really our unique selling point from BMW to create new algorithms It's more we should use these algorithms and implement that together with our business guys in robotics, in machine learning, in right engine, etc. And we will find here new solutions. And what I have learned, another point in the NISC area is you need very specific know-how for hardware to implement that. And sorry, from BMW, that is not BMW stake. Yeah. That means we have to buy this knowledge from other partners, from the big vendors like IBM, Google, or Microsoft, or from startups like Zapata, QC Ware, or 1Qubit.
Yeah.
So I would just build on those comments as well. In terms of the Air Force perspective and where we're going, we believe that the time is right now to jump in and get our hands dirty, if you will, with computing hardware, and not wait for these more sophisticated error-corrected computers to come along. And that's for a few reasons. But one, we need to invest and look at the technology now. And the way we do it, as I mentioned, partnering with some of the larger vendors out there as well as the smaller companies, but looking at a variety of solutions. And then specifically the areas we're looking at, optimization and quantum simulation as well as machine learning. Those are kind of the drivers for us. And realizing we're not going to be able to maybe implement what we really want on this computer right now, but kind of getting started and building towards the future.
For us, I would say that a lot of what we spend time internally is trying to adjust the tension between jumping in right now and handling the internal expectation of what is doable and what is not. We've been old enough to remember the AI winter, and people get overblown expectations of what is doable, and corporations have short attention spans. So navigating that line is something that we care a lot about.
It's a perfect seg into my next question, which is, you guys are all from massive organizations that oftentimes are pretty opaque to people on the outside in terms of how they make decisions and operate. And I'm very nervous around expectations getting too far ahead of where reality is today. But how have you seen things change inside your organizations the last year? Like, say, on the C-suite level, or we just heard from Major General Cooley, but so we kind of got your organization, how they think about this. But is there better acceptance of quantum, or is people still really healthy skepticism or not enough skepticism? How have things changed since we were at Q2B last year?
So I think there's been increased interest from more senior management, and we've done a lot of work with them to help them understand what the potential of the technology is, but also where it realistically is today. And so there's been a lot of discussion back and forth. I think we feel like this juncture is one where, even though it's hard to see a practical effect in the next 2 to 3 years, this is the time to jump in and think about our IP in the area, how we can think about building business value.
Yeah, I think for us at Airbus, we benefited very early on from a buy-in of top management. And last year we went through a bit of a change in some aspects of that top management. And the new guard coming in also is quite supportive and quite excited about quantum computing. So for us at a top level, it's been very easy. If I go down the ranks, I think what's been really nice to see is a coming together from different areas, different business units, people with different distances to quantum computing, some closer, some more distant, but generally an interest, genuine curiosity for the technology. There are at times a sense of how to use the technologies, maybe not clear, and this is where people like myself come in and try and facilitate the connections. And I can only echo what was said earlier by General Cooley in terms of fostering this connection with the outside ecosystem. For us, our expertise is really in the aerospace sector, and we're conscious of that. And so what we want to do to help harness and understand this and other high-performance computing system is to really try and work side by side in close collaboration with the outside world.
From BMW's perspective, as you can imagine, we have a big change in the automotive industry. That means we have to go to autonomous cars with machine learning and all this stuff. on the one side. Then we have to go from the combustion engine to batteries or fuel cells in this way. And our whole business model could be changed in the way for a platform or decentralized platforms in this way. And so we have a lot of working place there. And for sure, that is a challenge in this time to involve in new technology which will not bring at this time a real business benefit. And I said to some colleagues yesterday, it is like to prepare for a 100-meter run where you do not know if where it will go and when it will go, but you have to be prepared in order that the start would beginning. And so to look back, I took part at the last Q2B conference, and I could say nobody inside BMW from management area knows very well about quantum computing. And the guys from Google and IBM came to us and said, okay, would you like to join to our partner program? And nobody knows what's and why. And in this year, I think we have now a clear view to the actual status. We will continue our activities, but we will not jump with a big effort in this area.
Yeah.
Yeah.
So General Cooley obviously did a great job summarizing the Air Force's interest and AFRL's interest in quantum technology. The one thing I would point out over the last year, we spent a lot of time and effort in educating higher levels of the Air Force in terms of senior leadership. And it's been great to see their interest in quantum and quantum information science and where it's going. But we've really been very careful to make sure we do a lot of education there and get away from the hype and separate fact from fiction and what other nations are doing as well. So that's led us to really develop a quantum strategy for the Air Force that General Cooley laid out. And now what we're doing as we go forward this year is really growing that into partnerships across the whole of government. So General Cooley talked about working with the Air Force, the Air Force working with the Army and the Navy, but then also other government organizations such as NIST, NSF, DOE, where we can really pool our investments and get the most bang for our buck. So that's where we see ourselves going forward in the future.
Yeah.
And for us, I would say, and probably more generally for retail banks, I think that the conversation is moving from maybe 2 years ago, either absolute lack of awareness or this is not for us, this is for chemistry, pharma, other industries, to probably 1 year ago, more awareness, so especially on security and cryptography. So fear is a very good motivator for banks, so that helps a lot. And that's moving now to, hey, tell me more, what can we do, which type of problems can we attack on this? But it's still not well understood on the upper ranks of banks.
So, Ollie, you were an overachiever and prepared one slide. Can we tee that up and?
Sorry.
No, it's fantastic, and quantum touches a lot of other technologies, and your job is to scout a lot of advanced technology. So, how do you view kind of quantum in this broader landscape?
I created this slide in order to show you a little bit what is the process to identify technologies and to bring it into the organization. Because as I mentioned, that is my actual business and it's quite similar. And in the first step in June 2017, we identify on the technology radar quantum computing. And we have to decide, okay, is it now the right time to go in? And we decided that. And next steps is always the same. It's a technology report, an internal technology report, where we checked what is the technology, what are qubits, and all this stuff, yes? And then what are competitors, what Volkswagen makes, yes? Volkswagen is a big example for a big communication, quantum computing. And then we have to examine the provider landscape And after them, and I think that's the biggest challenge in order to have a meaningful risks and challenges and chances, we have to identify use cases. And a big advantage for that was in Europe, we founded together with Thierry, with Siemens, with Bosch, and some other industry partners. We have founded an open technology, open quantum computing technology group, where we discussed possible use cases. And so that helps us very good to identify inside a BMW, inside a research department, inside plant, inside sales, possible use cases. And then we decided, okay, we should go to the next level, to the third. We will go to proof of concept. This is normally the way of thinking. And so we need some quantum computing expertise. We buy it on the market together with QC Ware. And not only QC Ware, is also some Japanese guys from the university and some other. But QC Ware was our main partner in this way to improve our skills, to discuss these use cases together, and last but not least, to implement all these use cases. And that you give an example what kind of use cases that are. That was more or less low-hanging fruits at this stage, and we used annealing use cases, more or less all travel salesman problems. One in the mobility area, that means here we optimized in our right engine, similar to the Uber right engine, passenger requests to cars. That was one use case. The second use case was in the plant. That was an optimization with robotics, and last but not least for machine learning and Boltzmann machine. And then we got some results. And the next step was, okay, with this result, we know a little bit how mature is the technology. We are going to Rigetti or whatever else in order to get the roadmaps. And then we can see, okay, when is it possible to implement this use case fully blown? Yes, and the last step was we have to make sure that that is not a unique activity, that the activities will continue. And so we placed in the research department, in the IT department, some colleagues which are involved or which are responsible for all this stuff. Yes, that is the typical way of thinking for quantum computing, roundabout more than 1 year.
Yeah. I would imagine the rest of you are probably structured in similar ways, like working towards proofs of concept, but any major differences that anyone wants to highlight? Otherwise, I'll move to the next question.
So I guess, we started thinking about quantum actually maybe about 4 years ago, and so, learning about it from various partners that we've been working with. This was before even we started our formal R&D effort. Mm-hmm. But, I guess the one other thing I would say is, we're thinking about, you were talking about sort of purchasing the knowledge, but like, since we have our own R&D effort, we're also thinking about IP creation and things like that.
So is there a major milestone in the field that you guys are tracking that you think will be a step function change in kind of the attention that your organizations give it? Like, if so, would that be supremacy? So kind of say an academic, proof of where the field is at, or to be more of actual like quantum advantage for something that, for a problem that you guys deal with, on a daily basis in your organizations, or some other milestone? And if not, like, what are the metrics you're using to evaluate where the field's at and how many resources to devote to it?
I think one of the interesting things that came up at last year's Q2B was the advent of sort of a kind of Moore's law for quantum computing. The fact that the quantum technology is getting exponentially better over time, whether it's by fidelity, number of qubits, or whatever. All those metrics, just like the semiconductor industry, are going on an exponential time scale. And so when you talk about the threshold, it's not really that. It's that whenever you have something that's improving exponentially, it'll be under the radar for a long time, and then suddenly it'll seem like it's just come into being. And so you want to be ready for that time when that comes. It's going to feel very sudden, but that's because it's an exponential improvement. And so that's why we want to sort of get ready now.
Yeah, you talk about a milestone. So I think for me, it's hard to boil it down to just one marker. Rather, I look at many individual indicators. Just to see the size of the crowd today at Q2B, I think is already speaking volumes in terms of how the field is evolving. More and more people are interested. One can look at government funding. In Europe, for instance, this past year, there was the kickoff of the Quantum Flagship Initiative, 1 billion euros over a 10-year period. It's mobilizing a big community. It's bringing a lot of people together. We can also look at the quantum supremacy. You referenced that as well. I think that'll be another big marker when it happens and when there's sort of an agreed stipulation on the part of the scientific community that yes, indeed, this has now been achieved. All of these are, I think, important steps. For me, coming from an industry perspective, I think if I had to pick out one important marker, one important milestone, is to see one area, one application, it doesn't matter if it's in the aerospace industry or another industry, where quantum computing becomes implemented as part of an overall either production or service that is being delivered. I think that is likely to open the floodgates, is likely to further motivate industries, companies to look into it for their own sectors, no matter which one it is. Yeah. That first breakthrough, I think, is going to be a very, very big marker. Mm.
Yes, to be honest, quantum supremacy is not the big thing for BMW because it's more or less a theoretical thing. Our next expectations for quantum computing is we have to make experience in gate-based quantum computing regarding batteries, chemical simulation, all this stuff. And then we have to decide we find two things. The first thing is we have to secure some IP in this way. And this is always a good thing in order to be prepared for the future. And the other one is we have to find real business values. And it could be that we use there not purely quantum solutions. It could be, but to be honest, it's relatively important that we use a hybrid approach for quantum-inspired software simulation, like the Atos quantum learning machine or the digital annealer from Fujitsu or whatever else. We have there always some good experience in this way. And so for me, to be honest, it's not so important. Is it a fully complete, clear quantum computing approach? For me, it's important what is the business value behind. Yeah. And hopefully we found it in the next year.
So from our perspective in the Air Force, I don't think there's one particular event or milestone that we're really looking towards, such as quantum supremacy. Maybe a quantum advantage in a certain area will help drive us and push us forward, but the topic here is certainly within the next year, but we realize we're in it for the long haul in the Air Force and the DoD. So what we really see ourselves doing, we talked about those partnerships, but also growing our workforce. I think that's something I want to hit upon as well. General Cooley talked about it. And that's where we see added investment by the Air Force in being able to not only on the government side, but our contractor workforce, academia, students, things like that, really training them and seeing if it's not a near-term application, but what can we do longer term and what can quantum really be used for, quantum computing be used for. And we're looking at things, pretty novel ways of doing things like what we're calling an open innovation campus, where for doing very basic research, how can we work with some non-traditional partners, outside the normal Air Force confines, what we call the, outside the gate, and develop some unique access there where, as we have access within the Air Force for hardware, these prototype computers, how can we bring others in that are partnering with us to be able to really leverage and multiply our workforce that way and what the Air Force is doing.
We intentionally avoid the discussion on advantage or supremacy internally. It's a shiny object, but we will not assign resources based on that. For us, it's more important kind of understanding inevitability. It will happen at some point in time, and the technology will be part of the stack of the bank. So we're very much going towards building the talent and the IP to create that optionality, regardless of when it actually happens.
So with that, we've got another 10 minutes or so. I want to open it up for questions from the audience. Maybe first, just a quick round of applause for our panelists. And now take questions. We'll apply General Cooley's rule if we need at least 3 questions. All right, Jake, we'll start with you.
So thank you very much for those wonderful remarks and deep insight for this community in terms of your perspectives. One thing I heard mentioned quite a lot is the value of the intellectual property that you're developing. And I'd like to understand a little bit better, from your perspective, the balance between proprietary knowledge, intellectual property in the form of people who know what to do, and intellectual property in the form of patents and things that you can start to share to external partners. Like, what does that balance look like for each of you?
Go for it. So, we're a commercial organization, so we of course have to think about what is our advantage going to be. At the same time, there is a large community out here making progress on a lot of different things, and that's going to be much bigger than anything that we ever do. So we focus kind of on the core applications, like for us, things like speeding up Monte Carlo simulations or something like that is a core, business competency that we have. And so we focus our areas on specific applications where we think that, that would give us an advantage. But obviously, we're also working with the outside community, and that we stand on the shoulders of that larger community. So we're very cognizant of that.
Yeah, I think the point of IP, intellectual property, at this stage is a very difficult one. I think we're in a very early stage still for quantum computing. So to be too secure, too closed off, can also lead to, I think, maybe a slower progress of the overall evolution, and might be a little bit detrimental also for the company at play. I think for us, we're certainly very careful about trying to find that balance. We're still at a point in time where we really believe in that close proximity with the overall ecosystem. So we try and maintain a rather open, rather outwardly facing, I think, position. And at the same time, sort of monitoring evolution, monitoring progress, and sort of informing ourselves as to when we might want to change our positioning, our posture. But at the moment, I don't believe that the time is right. I think it's still important to be, as we are here today, exchanging, talking, discussing, and openly sort of fostering development. It's going to take still a few more steps until the know-how progresses to a point where very, I would say, secure and important IP can be produced.
To be honest, I am in the department from open innovation, and that means we have to be very open in order to develop further activities. That's first thing, and as I mentioned, we founded also an open quantum computing community. But by the way, we examine also some activities for patent work, but they are not finished. In this way, we are on the way, and we have to looking for what are the results. Yes.
So I'll be very brief with this one. Since General Cooley covered it, and I thought he did a great job with it, was, we're right now at the early infancy of quantum computing, so we're all about the information sharing. I talked about potential for our open innovation campus, bringing outside and maybe non-traditional partners into it. So we're very much about presenting publications, patents. That's something that drives us as well. But then as things mature down the line, then we'll have to take a closer look at how we pull things back and in terms of getting actual use cases that are advantage to the Air Force. Then we'll have to bring those closer hold.
I think in general, banks, with the exception of Goldman Sachs, who has been very good at that for a long while, have not been very good at formalizing IP. I think that our patent office was established 2 years ago, and many of my colleagues don't have a patent office in their organization. Having said that, for frontier technologies, we believe that the rising tide will lift most boats, so we're very much about oversharing and engaging with the system.
All right, one question down. All right, I saw your hand first.
If the customer's always right, what would you recommend to the companies in this room to better serve you as customers, whether that be the hardware companies or the software companies or whomever, to better help you get to where you need to go?
Maybe I'll take a first stab at providing an answer. I think if there was one element that could help us, certainly speaking on behalf of Airbus, but I think through conversations with other colleagues from other industries, I know it's also a question mark they've had, to have a way to benchmark the capabilities of different quantum systems. A year ago, there was a presentation where the idea of a quantum volume was presented. I'm not saying it's necessarily the best definition, but at least it was a definition that could potentially be used. And I think for the community, for the quantum computing community, to come up with some benchmarking method to help us identify and be able to ascertain the capabilities of one quantum system versus another is, I think, really important. And I would anticipate that certain computers will naturally be better at answering certain types of problems and others other types of problem. And again, to help us sort of see clear through all of that maze, that jungle of possibilities, I think would be very helpful.
Anyone else want to field this?
Yes, I have to say the key success factor for BMW was you have to jump into the quantum computing world. That means you have to think about use cases, you have to realize use cases together with partners, and then you have to examine the results. Otherwise, for me, it's not possible.
So I would just add what Dr. Preskill, Professor Preskill said this morning, certainly better qubits, right? It's not just sheer number of qubits, but how can we practically make qubits? And IBM has a great chart. It was shown yesterday, and I'm not sure if Jerry will show it next, but certainly showing the qualities that you need in a qubit. And I think once we get there, the field will really just start taking off from that.
Yeah. All right, one more question. Yeah, I saw that hand.
So a lot of you talked about like the readiness, but part of the readiness is that you have the necessary expertise in-house. How do you do the workforce development?
Sorry, what was the question?
So I think that the question was readiness is important and how you need technical expertise to evaluate the residents, and how does that work in-house? Mm-hmm. Ollie, did you get there?
Yes, that's some experience, some experience. Quantum computing is, for the normal BMW colleagues, a totally new area, yes? And if you come with this technology and with this knowledge, you will have some big stones in the way. And actually, our success story was we have inside BMW a PhD network. And we use this PhD network. There are some PhD in different departments which have optimization tasks or whatever else. And we explain that, what quantum computing is, what are the possibilities, and they jumped to the train of quantum computing in every proof of concept in this way. That means we recruit our quantum computing skills or our staff in our PhD area. And that was our way of thinking.
All right, got time for one last question.
Hi, thank you so much for giving us insights into how you believe that there might be solutions to actually address integrating quantum computing. Now, I'm actually curious, since you all represent very different industries, what do you think the main barrier to entry is in terms of convincing not only the people who actually drive decisions at the top of your respective industries, but also your consumers? I would love to survey that opinion, and maybe the unlocking power of this question will provide fodder for everyone in the audience.
I'll take it first. About the consumers, I don't think that they will care or they should care. I think that it is part of our job and the job in this room to make that transparent for consumers. One thing where I believe that we can get a lot of help from you guys is on what Oli was referring to, use cases in the industry. So the main expertise on the technology will happen, and it's happening already. Translating that into something that you can sell internally that will fix a business problem is part of the job that you and us need to do together.
I would just echo that as well from the Air Force perspective. Use cases are something that we really need to come up with and develop and show where quantum computing could be useful. We envision a lot of things where it may be useful, such as asset optimization, things like multi-domain command and control, where you're looking at airspace, cyber type effects and how you can optimize that, just as well as scheduling of resources. And then you look on the other side, autonomy. How can you apply machine learning to some of our tough problems as the Air Force really changes and its shift in its focus. So development of those use cases and where quantum computing make a difference will really help us going forward.
Yeah, for us, getting industry expertise and partnership to look in detail at the use cases that we're thinking about and prove out these use cases as real applications, that's powerful.
I think, if I may, your question was also pointing to the next step, sort of outwardly towards our customers. So, in our case, as an aerospace solution provider, our customers are ultimately interested by the platforms and the services they can get out of these platforms. And so the biggest markers for them will be in seeing an enhancement in the performance of those systems, in management of fleet and optimization of the parts distribution, whatever the case may be. So being able to demonstrate those gains, it'll be an indirect demonstration of the power of quantum computing. How that actually happens is, of course, hopefully our ability and our capability of delivering new, better services. And I think that is the end element that our customers will see, is that improvement in the overall portfolio.
All right, with that, I think we're out of time. Thank our panelists one more time, and we'll get out of here.